Hey kids, time to do polar equations, right? This brand new way of graphing and representing points in space, right? We spent the last video talking about plotting points and representing these points either in rectangular form, right? If I have the point 3 comma 4 in rectangular, that means to go 1, 2, 3 steps in the horizontal and 1, 2, 3, 4 steps in the vertical, right? Rectangular. But if on the same axes, I want to represent getting to that spot with from the pole or the origin, how far did I radiate out? How far did I radiate out to get to that spot? And how far from the positive horizontal axis did I rotate? And I taught you how to put, right? The radius is 3 squared plus 4 squared, and theta is inverse tangent of 4/3, right? We did that yesterday. So I want to now I want to move past points and we want to talk about equations. So yes, I want you to convert between polar and rectangular equations. But the goal here, I want you to be able to identify or match polar graphs and equation. And you take for granted being able to do this in rectangular form. If I gave you these two equations, y is equal to 3x squared plus 2, and y equals negative 3x squared plus 2, and two graphs. Could you match the equation and the graph? Right? Yes, because you know the characteristics. A squared means I have a parabola. A leading coefficient that is positive means I open up. A leading coefficient that is negative meaning I open down. That goes with that one, and this goes with this one, right? You identified and matched. Parabola, right, opens up. Vertex at 0, 2, right, opens up or opens down. That's identifying and matching, and you are very used to that in rectangular form. So the idea of converting first is to take a polar equation and get it into rectangular form, and then you see the rectangular form and you go, oh, that's my old friend, a parabola. That's my old friend, a line. Okay? So that's first what we want to do. But then we want to get to the whole point of wanting to graph in polars is to get these shapes that we don't have a nice representation for in rectangular form. And we have a nice, clean way to represent them in polars, right? So that's where we're going. So let's start reminding ourselves of the formulas from yesterday. Just from my unit circle, x is the same as the radius times the cosine of theta. Y is equal to the same as the radius times sine of theta. And then the radius squared is just Pythagoras, right? Or the radius would be the square root of x squared plus y squared. I should have also put up here theta, right? Since tangent of theta is equal to y over x, theta is equal to inverse tangent, which has some restrictions, right? And I'm also dividing by x, which has some restrictions. So there's some issues with there. So let's see if we can convert these four equations. I don't recognize these. I don't know what they are. But so in order to identify them, because that's really my goal, right? My goal isn't just to convert. I really want to be able to identify what I'm working with. But they're in polars, and I don't recognize them. I've only been working with polars for one day. So I have some conversions. My conversions are in x and y, which is rectangular, where I'm comfortable. I am comfortable in rectangular. So if I take this equation and put it in rectangular form, maybe I can recognize it. The first thing I think is I'm not really psyched about secant, so I use an identity. Oh, hey, here is r times cosine theta. Can't I multiply both sides by cosine? What do you have now? R cosine theta is the same as x. And don't you recognize that graph? Right? The slope is numerically undefined, but that graph is where x is always 3. This is the graph of a vertical line. I didn't recognize you in polars, but when you say the radius is always equal to 3 times the secant of the angle, put your calculator in polar mode. Go ahead, do it. Put your calculator in polar mode and graph 3 divided by cosine theta and look at that graph. Hit zoom 7, right? Zoom trig, which sets a negative 2 pi to 2 pi window, and look at it. It's a vertical line. Want to take any guesses as to what the next, because after all, I just want to try to figure out some patterns here. Want to take any guesses as to what this is? Let's do the same thought process. Don't really like secant so much, cosecant so much. That is a reciprocal friend of sine. Multiply both sides by sine. Oh, hey, r sine theta is the same as y. Oh, I recognize you, right? I know what you look like, just like I knew what you look like. This slope is not undefined. This slope is 0. But y is constantly 3 is just my old friend, a horizontal line at 3. Who would have known that r equals 3, the radius is equal to 3 divided by sine of an angle, or 3 cosine of that angle? A horizontal line at a height of 3, a vertical line at the x-coordinate 3. So what the hee-haw is this, right? So here's what I was alluding to in the first slide. If I just go about converting this, hopefully, right, r is equal to the square root of, oh, my dog, is equal to 1/3 inverse tangent of x over y. What the hee-haw? I do not recognize you in polar form. Sorry, I have to bring my dog in. Pause. Dude, come here. You cannot be barking out there late at night. Come here. Let's go. In. Come here. Let's go. Come on, pups. Thanks for waiting. Hopefully you were maybe on your calculator at that point, right? Playing around. But this, firstly, go ahead, try to put this into your calculator in rectangular form. Ew. And I don't even know what that is. I have no idea what that looks like. I made quite a leap there from just drawing a simple vertical line to a horizontal line. All of a sudden I got this nastiness. What the heck? Well, actually, maybe polars is a nicer way to think of this equation. Rectangulars let me down. Rectangular, you broke my heart, right? I do not recognize you. But can you think about what this might be in polars? The radius is always 1/3 of the angle. Well, what about when the angle is 0? What's 1/3 of 0? 0. Your radius is always going to be 1/3 an angle, and we're going to start at 0 and go to 2 pi. So our angle is going to get bigger and bigger and bigger, and I'm going to sweep out here. A larger radius is going to go here, a larger radius here, because I'm rotating, right? Here. Go ahead and graph this on your calculator. That's what you're going to get. And if you make your thetas go for longer and longer, you're going to keep spiraling. Why? Because your radius starts at 0, and your radius, as you rotate around, your radius is getting longer and longer and longer. Forever. That's going to keep going. It is a beautiful spiral. I did not recognize that. Notice that that spiral is not a function. Look at its rectangular form. Boo. Look at its polar form. Beautiful. Very simple, elegant expression for a very pretty graph. Polars are pretty, right? And rectangular, not always. Now, I would agree with you that x equals 3 is a simpler version of a vertical line than r equals 3 secant theta, right? I don't think I need polars for a vertical line. I don't think I need polars for a horizontal line. Although, truth be told, for my vertical line is not a function, but r equals 3 secant theta, r is a function in terms of theta. That's handy as well. Taking something that's not a function in rectangular, converting it to polars where I can do some function math on it. Crazy. Let's look at this. This looks horrendous. What the heck? What can I even do with that? Right? Can you see anything to do? I got cosine theta and sine theta, but I don't have any. I can't go directly to x, can I? Right? Do you see that? Well, think about what we did over here, right? Didn't we multiply to get the trig stuff over with r? Can we do that here? Let me draw a little line here. What if you multiply both sides by this whole freaking denominator? You get r times 3 cosine theta minus 2 sine theta is equal to 4, right? I just multiplied both sides by the denominator, distribute the r. Oh, snap. 3r cosine theta, hello, x, minus 2r sine theta, hello, y. So I certainly didn't recognize this in polar form, but what do you have now? Minus 2y. What is that? Everybody's to the first power. What is that? That's it's not a horizontal line. It's not a vertical line. It's a diagonal line, right? X to the first and y to the first, diagonal line. Well, that's crazy. Let's graph it. When you put 0 in for x, y is -2. When you put 0 in for y, x is 4/3. So that equation in polars was a diagonal line. I certainly think that the rectangular version of a diagonal line is a little simpler, more elegant than the polar form of a diagonal line. Same for a horizontal, same for a vertical line, right? And except for the issue of this vertical line is not a function and its polar equation is, Certainly r equals 3 secant theta doesn't seem like the most efficient way to represent a vertical line. But the spiral here in red, the spiral equation is a lot better in polars. Now, it's a very simple function, even though in the xy plane that graph is not a function. But I can represent it in polars as a function and in a very simple equation, r equals 1/3 theta. I don't think I would bother representing any diagonal lines with this polar form, but I can now match it, right? So the point here being is that sometimes I give you polar equations, you might need to go to rectangular in order to figure out what it looks like. But I'm going to give you some more as we move along where you do not want to convert to be able to recognize it. So let's look at these. These are ones that are not bad to convert, but I'd like for you to be able to recognize a pattern and not have to convert. So the issue here is I really, really, really want cosine theta to be with the r because that's x. So there's a little trick here. Unlike before, remember that in the previous slide, if this had been 4 divided by cosine, 4 times secant, I would have no problem. But it ain't. I really, really, really want an r here so that I can write this as x. That's legal if you also multiplied this side by r. So then I end up with r squared is equal to 4r cosine theta. And then I recognize I can use my formulas, right? And I have a formula for r squared, and I have a formula in terms of x and y, and I have a formula for r cosine theta. So this is x squared plus y squared is equal to 4x. If your directions just ask you to convert to rectangular, you can stop here. Stop. You have done it. You've gotten rid of r and theta, and you have only x's and y's. But if you are also asked to identify you took conics and AAF. I can't spell identify, right? You had the conics unit. It was the end of the year. It was remote. Maybe you didn't pay attention. Well, go back and watch the videos. The leading coefficients here of x squared and y squared are both the same and both positive. This is a circle, which is not a function in rectangular, but it is in polars. Look at this equation, what I started with before I messed around. R equals 4 cosine theta is a circle. Talk to me about when theta is 0. When theta is 0, R equals 4 cosine theta. What's cosine of 0? Right? The radius is 4 times cosine of 0. Well, that's 4. So from the pole, there I am at 4. Now I'm going to start to rotate. Cosine oh dear. Oh, that's a terrible circle. Now, what if I asked you to match and there were a bunch of circles? How do you know which circle it is? Well, again, you took AAF and you paid attention. You've got to take this equation and find the graphing, translate it from rectangular standard to rectangular graphing. So that means you have x squared minus 4x plus y squared is equal to 0. And no, I'm not going to go through this slowly because you did this last year. You're going to complete the square. And now I'm in graphing form where I can see that the center of the circle is 2, 0. Okay, so If, again, you are just asked to convert, stop here. Stop. But if you need to match or identify the characteristics of that, you want to be able to say it is a circle with a center of 2, 0. Now, I want you to notice something else that's kind of cool. I'm going to do a little bit better job of drawing this. Oh no, I think maybe I did. I captured this on my from my calculator. So if you want to go ahead and put 4 cosine theta into your calculator, I want you to train your brain to think about graphing in polars, right? When theta is 0, I'm at the point 4 comma 0. Hit trace now and trace around. When cosine of, what's cosine of pi over 2? Cosine of pi over 2 is 0. What's 4 times 0? 0. So your radius is going to shrink from 4 to a radius of 0 as you rotate. Right? Then you're going to say cosine of 2 pi over 3 is negative, right? Negative. And you're actually going to trace this twice, but there is my circle with a radius of 4 and a center of 2 comma 0. R equals 4 cosine theta is a circle, and it's kind of oriented. Think about it as oriented around the positive x-axis, right? Do you see that? Do you see the symmetry around the positive x-axis? And what letter, rectangular letter, do you associate with cosine? X. So can you make a guess as to what this shape is going to be? For sine theta? Talk to me about when sine is 0. Where are you? When you put in 0 for theta, sine of 0 is what? 0. So your radius is 0. What about pi over, as you rotate around, what about sine of pi over 2? What is sine of pi over 2? 1 times 4 is going to be 4. So you're going to rotate around, and your radius is going to go from 0, and it's going to grow, 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 grow until it's a length of 4. And then it's going to come around. Then the radius is going to get smaller and smaller and smaller. Notice that r is equal to a constant. Sine theta is also a circle, but it's oriented where? Positive y-axis. And what rectangular letter do you associate with sine? Y. Pretty cool. What's the rectangular version? What's if I haven't converted to rectangular? Right? What's my trick? Multiply everybody. Multiply everybody by r because I want r sine theta. So I get r squared is equal to 4r sine theta. We know that's y. R squared is x squared plus y squared. If you are just asked to convert, you can stop there. If you're asked to identify, hopefully you recognize that's a circle from either here, the polar, and if somebody asks you to graph or where the center is, you need to complete the square. right? So this is a circle with a center of 0, 2 and a radius of 2, right? Because this is radius squared. 2, 0, radius of 2. Okay? So, again, think about what you're asked. Are you asked to convert? Well, then just use your algorithms and convert. But try to think each time what is happening. Could you just, if you were asked just to match, you don't want to have to go through conversion all the time to be able to match. You want to be able to trying to start see some patterns. It's going to take a while. You've just started with polars. Let's go the other way. Convert this equation to polars. So I'm in x and y, and I want to get to y and I want to get to r and theta. So I'm in the graphing form. I hopefully from AAF I recognize what this is. This is a circle with a center at -4, 3 and a radius of 5. But to get it into polar coordinates, I need to have, right? I need to have some x stuff. So I've got to quickly, I took Algebra 1 and I paid attention. So I have x squared plus y squared. I know what I'm going to replace that with. So that's one thing I'm going to be able to do. I'm going to get everybody over to the other side. What is that? -8x. And then plus 6y. And then I had a 16 over here and a 9 here, which is a 25, which canceled out with that 25. So I just have a plus 0. So let's go to our formulas. I can replace x squared and y squared, and I can replace x and y. X squared plus y squared is equal to r squared. -8r cosine theta. That's what x is. Plus, that's a plus, right, because there was a minus on this side. 6r sine theta. You could leave it like this, but remember, I want you to untrick this. Right? Do you remember the trick when we were going the other way where we needed an r? I want you to get rid of the r, right? Divide through by r, because if r equals 0, we'll make this equation true. But I want not r squared by itself, I want r. So divide through by r. That, in polars, is a circle with a center of -4, 3 and a radius of 5. That's what that equation is. I didn't recognize it in polars. I did recognize it in rectangular, but notice that in rectangular form, I don't have a function, and in polar form, I do. Right? The whole vertical line test, right? That's on rectangular. Crazy. Oh, look, I'm in a rose. Oh, how nice. All right. I am going to always give you your calculator if I want you to quickly graph, right? I don't want you to spend, you do need to understand plotting points, but we at this point are trying to build the skill of what do these things look like just like you did in Algebra 1, where you plotted some points, but then you got out a calculator and you started graphing lines, and what happens when I change the slope from positive to negative, what happens when I change the y-intercept, what happens if I have the same slope, right? And you did all of that with a calculator, and you looked at, rather than plotting every point. So yes, I need you to know how to plot some points, but I don't need you to do that every single time. So graphing this, r equals 6 cosine theta, nope. R equals 6 cosine 3 theta. So remember, I've changed, right? Remember what this did? I've changed the period. B is equal to 3. And remember when in AF I had you write out, and we did this in pre-cal too, what does this mean? 3 is not the period. 3 is how many cosine cycles you see in a distance of 2 pi. So I can quickly, what if I'm going to pretend, wink, wink, I'm going to pretend this is y equals 6 cosine 3x. And I'm going to graph that. I taught you how to do that with the road, right? The amplitude is 6. There is no sinusoidal axis. Here's 2 pi. You need to get me 3 cycles in a distance of 2 pi. The dilation factor is positive, right? So I'm going to have, oh dear, 1 cycle there, another cycle there, and another cycle there, right? 3 cycles in a distance of 2 pi. When I'm going to graph this in polars, it's still saying the same thing. It's still saying that you're going to put in theta, right? And talk to me about when theta is 0. What are you going to get? Theta is 0, 3 times 0 is 0, cosine of 0 is 1, 1 times 6 is 6. So I'm going to radiate out. My radius is 6 when theta is 0. I didn't rotate any. Now look here, what happens? I stay positive, but then go to 0. So in polars, my radius is going to shrink to 0. So as I rotate around, my radius is going to go to 0. Right? So, right, radius 6, radius shorter, 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 0. Then look what happens as you start to go around more. You negative. And then you come back to 0. So rotate in polars, rotate theta, right? And then your radius gets bigger and bigger and bigger and bigger until you get back to 0. Then you positive. What ends up happening? Can you see what this looks like? And have you put this into your calculator yet and look at it? This actually looks like that. And I kind of oversimplified the situation. You don't actually trace it. When you start at 0, if you hit trace, you do go this way, but you don't go this negative here. You go negative into negative x's. So you travel this way. That, my friends, is called a rose. Personally, I think it looks like a flower and not a rose, but I didn't get to name it. Each petal has a length. How long do you think each petal is? 6. Each petal has a length of 6. Hey. How many leaves did I have? Hey. Petal length. How many petals? Look at that one petal that I traced illegally. I just was trying to highlight the first petal that you look at. Look at that petal. Where is it kind of oriented around? Cosine. Oriented around the x-axis. Now, not all of them are, but in the positive x-axis it is. Right? The quote-unquote first petal. Crazy, right? And it's a pretty graph. It's a pretty equation and it's a pretty graph. Let's do another one. There's a much prettier graph. And I left the axes off, right? On purpose. I wanted you to see, right, the cosineness of that 3-petaled rose. So what do you think this is going to look like? 6 sine theta. Remember, if you think about not converting to rectangular, just wink, wink, pretend this is y equals 6 sine 3x, right? Same thing. In a distance of 2 pi, you've got to get 3 cycles of sine with an amplitude of 6, starting at the origin. 1, 2, 3, right? With a height of 6. So think about that in polars. What's that going to look like in polars? What is 0? Sine of, right? 3 times 0 is 0. Sine of 0 is 0. 0 times 6 is 0. So let's take a guess. Pattern. What do you think the length of each petal is going to be? Good. How many petals do you think they're going to be? Good. Sine goes with which axes? Y. So you should see some orientation around the Y. So I bet it's going to look like this. Going to be 1 there, and then I don't know, maybe 2 more here. Don't copy that down. Put this in your calculator. 6 sine 3 theta. Make sure you're in radians. Is this the graph you get? No. Sine starts off at 0 and then goes with this 3 theta. It reaches its next distance radius of 6 out here at like a 45-degree angle. There's your length of 6. There is a Y orientation. Okay? It just doesn't quite fit my pattern because the surrounding of the y-axis is in the negative direction. But that just is a factor of what sine does when you put in theta and multiply it by 3 before you take the sine. Okay? And again, you can just Hit trace and watch as the radius grows to 6 and then shrinks. Right? Starts at 0, goes up to 6, comes down to another. Even this is -6 in rectangular. It's still a radius of 6, right? Cool. All right, so we've started to establish some rose patterns. R is equal to some amplitude, sine, I don't know, let's call this B theta. And again, remember that A is going to be the length of your petal, and B is going to be the number of petals that you have. And this could be either sine or cosine, right? And you remember that you have one petal for cosine around the positive x-axis, but for sine, you have one petal surrounding the negative y-axis. All right, cool. So then this should be easy to match. Look at these next equations. This should be a rose because I have amplitude, sine or cosine, B, which tells me how many, right, times in a distance of 2 pi. I've got to complete a cycle, right? So 2 of them. So gee, but am I going to have only 2 petals? That's not really a rose, is it? Put this in your calculator. Do you get a 2-petaled rose? No, you don't! You get a 4-petaled rose. What the hee-haw? This time, though, you do get the orientation around sine, around the positive and negative y-axis. But you also get the positive and negative x-axis. So it is cosine. You do get the positive x and y. I'm sorry, positive and negative x-axis, but you get the positive and negative y as well. Well, that doesn't really fit my pattern. Well, the 6 is still the length, though. The 6 is still my length. I do still see an x orientation, but I also see a y. But the 2 is certainly not the number of petals. Well, I wonder what this looks like. Put that in your calculator. What do you get? You get petals with a length of 6. You don't get any orientation around any axes. You get all petals at kind of sort of at like the 45 degrees. Oh, those are terrible leaves. But you get the idea. Notice that if you just take that 4-petal rose and rotate it, click it a little bit, can you see that you would get the cosine, right, rose? So what's our pattern, though, with this? How many petals did I get with each of these? 4 petals. But yet up here, I got 3. What's my pattern? And if you want to just play around, you'll figure out that this will hold. So your pattern is that the dilation factor is the length of your petal, and B is the exact number of petals if what? B is what kind of number? Yes, odd. So the length of each petal is always the dilation factor, and then B is the number of petals if B is odd, or B is number of petals if B is even. Okay? So in summary, we saw some polar equations that gave us some old friends. Vertical, horizontal, and diagonal lines. We also saw some polar equations that gave us circles, right? And that was r equals a cosine of 1 theta, or a equals sine 1 theta. Those were circles. We recognized those rectangular forms, right? They were our conic sections from last year. Kind of a little bit nicer, I would say, probably in polar form. Then we had our shapes that we don't recognize in rectangular form, right? We had that spiral, and we've now had rows. There are more, but for right now, these are the shapes that I want you to be familiar with. I want you to be able to convert between polar and rectangular with all of these. I want you to be able to convert between polar and rectangular with circles, not with spirals or roses. I do not need those. They're rectangular forms. I can get this into rectangular form, but it's going to take a triple angle identity. Look it up. I don't remember what it is. The algebra's pretty nasty, right? So no, I don't want the rectangular forms of those. Not useful. And they're certainly not functions. The circle equation isn't a function either, but at least I can somewhat deal with it. Okay? So before we go, look at this one. What do you think this is? This is, right? If you just have r and no cosine and no sine, but you have theta, could you identify it? That's our spiral. Remember, we had that before. We had a spiral r is equal to 1/3 of theta. This is just theta squared. So again, your radius just keeps growing and growing and growing as theta grows. And it looks pretty, right? It's a spiral, which of course always reminds me of a snail. Seriously, I did this slide just so I could put up the Bitmoji with the snail. Ew. All right, I will see you in our next live session.